Yeah, and that's fine. It's just kind of what I was working on. Okay, good morning, everybody, and welcome to today's edition of MetalCon Live. Today is going to be third-party radiative performance product ratings and introduction to the new CRRC wall rating program. This is being presented today by Audrey McGarrell, a project manager from the Cool Roof Rating Council, or the CRRC. Today's presentation is being presented by the MCA, or the Metal Construction Association. Be sure that you check out the slide here with all the benefits of becoming a member of the MCA, including a 10% discount on exhibiting at MetalCon and much, much more. As I just mentioned, MetalCon is coming up. It's just around the corner, about 8 weeks away. Make sure that you register early before early bird pricing ends. That pricing ends next week. So make sure you order your tickets now so you can still get that discount. We are also very excited to be bringing back a fan favorite, the Architects Experience. It's a curated experience for architects, engineers, specifiers, and designers at MetalCon. So if you know of any architects that are interested in metal construction or utilizing metal in their designs, make sure you recommend them to our show. We'd love to see them there. We're also launching a brand new program called Future Leaders. Future Leaders is for anyone under the age of 40 attending MetalCon. This includes a special social hour, some special education from Dr. Melissa Furman, one of our keynotes, and it'll be a great opportunity to get to know other members of the industry in your age bracket. Next time on MetalCon Live, we will be presenting AISI S250, North American Standard for Thermal Transmittance of Building Envelopes with Cold Formed Steel. So this is coming up very shortly, and we hope you'll be able to join us for that. And last but not least, don't forget to fill out the post-webinar survey to receive your certificate of completion. And if you have any questions or comments, you can always send them to me in the chat box, and I'd be happy to send any technical help I can your way if something arises. And with that, I'm going to hand this over to Audrey. Audrey, take it away.
Great, thank you so much. Let me just get my screen share set up here. Okay, can you confirm that you see my slides?
I do see those. Perfect.
Excellent. All right, well, hi everybody. As Kaylin mentioned, my name is Audrey McGarrell, and I'm the project manager of the Cool Roof Rating Council, or CRRC. I want to thank you all for allowing me to speak with you today about our brand new CRRC wall product rating program. Some of the information in today's webinar will be kind of a refresher on information that was shared by my colleague Sarah Schneider to the Single Skin Metal Wall Program Panel Council at the 2022 MCA winter meeting. However, we're also going to provide some new information about the program and updates since the last time we presented about it. So before jumping into the CRRC wall program, I'd like to give a little bit of background about the CRRC as an organization. We are a 501c3 nonprofit organization, and we evaluate and label the radiative performance of roofing and exterior wall products. We provide a public service through product ratings, research, and education, and this supports the development of policies and programs centered around energy efficiency and mitigating the impacts of the urban heat island effect. We do this by publishing the radiative performance ratings of products in an online directory, and that data is used by policymakers and program developers to evaluate policy options, incentives, and programs. Though CRRC ratings are used in the development of policies and programs, the CRRC itself does not advocate for any specific requirements. The CRRC was established in 1998 through a collaboration of stakeholders. This included government agencies, energy utilities, environmental organizations, and industry. The primary purpose of the organization was to create a third-party rating system for the radiative performance of roofing products that would support compliance with California's energy code. We have since gone on to be a valuable resource that supports a wide range of codes and programs that promote the use of cool roofs, both here in the US and abroad. In 2019, our mission was expanded to include exterior wall products. One question we hear a lot is, why would the Cool Roof Rating Council be interested in walls? In short, roofs and walls are very similar. They both protect against the elements and can help reduce a building's solar heat gain. The same test methods can also be used to measure the radiative performance of both roofing and wall products. Additionally, up until now, there was no third-party rating system to support compliance and enforcement of the various codes and standards that require walls to meet radiative performance standards. This means that for years, there was no standardized testing or reporting of data and no comprehensive list of products available to the public. Further, the CRRC can leverage over 20 years of experience from running the CRRC roof program. And as a third-party organization, we are an independent, objective, and neutral entity to provide reliable data. Now I'd like to shift gears to give a brief overview of the various benefits of cool exterior walls as a tool for mitigating heat and saving energy. In order to appreciate the benefits of cool exterior walls, we must first understand the critical issue that is urban heat. Urban warming negatively impacts human health, quality of life, energy use, air quality, social equity, and economic prosperity. According to the UN's World Urbanization Prospect, more than 8 out of 10 Americans currently live in an urbanized area. And according to the US EPA, daytime temperatures in urban areas are about 1 to 7 degrees Fahrenheit higher than temperatures in outlying areas, with nighttime temperatures about 2 to 5 degrees Fahrenheit higher. This is due to a phenomenon called the urban heat island, or UHI effect, a phenomenon that is caused by high concentrations of dark impervious surfaces, such as roofs, walls, parking lots, and roads, combined with a lack of trees and green space. Tall buildings that block or slow air movement, known as urban canyons, also contribute to the formation of heat islands, along with waste heat released by vehicles and air conditioning units. Smaller heat islands can also exist within cities. These are typically areas with more dark surfaces and a lack of vegetation. These pockets of heat are often located in neighborhoods where people of color and low-income residents live. A recent study published by the journal Nature Climate Change projects that cities will be 7.2 degrees Fahrenheit hotter by the end of this century. In heat-stressed neighborhoods, this temperature rise will result in even more heat-related deaths and illness. Excessive heat can have a severe impact on human health. In many large urban centers in the United States, heat is the leading weather-related killer, greatly outstripping hurricanes, tornadoes, lightning, and blizzards, as stated by Christina Dahl, a senior climate scientist at the Union of Concerned Scientists, in a July 2021 article published in the Scientific American. There are also other negative impacts from heat, including heat illness, increased respiratory and cardiovascular issues, increased hospitalizations, as well as impacts on health services and disruptions to key infrastructure like power grids and water supplies. Heat also impacts energy use and air quality. When it's hot outside, air conditioning use increases, which puts a strain on electrical grids. This often can reduce in blackouts and grid failures. The increase in AC use also produces more waste heat, which adds further to the heat problem. Higher outdoor temperatures also decrease air quality by increasing the level of ground level ozone and slowing airflow. The increase in cooling demand from AC use can also result in the use of peaking power plants, which emit air pollution. One solution to mitigate the extreme heat impacts of the built environment is cool exterior walls. Cool exterior walls are a straightforward tool that some organizations are turning to mitigate urban heat islands and save energy. They are often a very cost-effective approach with immediate benefits, as compared to trees, for example, which take a longer time to grow and produce their shading and evapotranspiration benefits. Cool exterior walls help reduce indoor temperatures by reducing the building's solar heat gain, which in turn results in less AC use, which can save the building owner money. On a larger scale, they help reduce energy demand and strain on the electrical grid during peak times. This can help reduce brownouts and blackouts. This reduction in energy use also helps decrease the generation of greenhouse gases. Cool exterior walls also help reduce outdoor temperatures, which not only helps to mitigate UHI impacts, but reduces ground level ozone, which is a main contributor to smog formation, thereby improving outdoor air quality. In buildings that do not have air conditioning, cool exterior walls can help the interior be more tolerable during hot times of the day, especially in existing buildings, which can tend to have less insulation than newer buildings. This also can apply to air-conditioned buildings that are suffering a power outage. As I previously mentioned, cool exterior walls can help save energy by reducing the amount of solar radiation that is conducted into an air-conditioned building. A study funded by the California Energy Commission found that cool exterior walls will save energy in residential and commercial buildings in all of California's 16 climate zones, as well as US climate zones 1 through 4, which is basically the southern portion of the United States. A cool exterior wall is one that highly reflects sunlight and efficiently emits any heat that is absorbed. This lowers the surface temperature of the wall and the temperature of the building's interior by limiting solar heat gain. Additionally, the greater the number of buildings in a given area that have cool exterior walls, the lower the outdoor air temperature will be in that area. The metrics that determine the coolness of a wall are solar reflectance and thermal emittance. Solar reflectance, or SR, also known as albedo, is the fraction of solar radiation that is reflected by the wall surface. Thermal emittance, or TE, is the relative ability of the wall surface to re-radiate any heat that is absorbed. Both properties are measured and rated on a scale of 0 to 1, where 1 is the most reflective or emissive. We'll talk a little bit more about measuring solar reflectance and thermal emittance later in this presentation. Another important factor in evaluating cool exterior wall materials is weathering. Natural aging is crucial for understanding a product's radiative performance over time. In particular, it helps us understand how soiling and weathering affect the radiative performance of various exterior wall products. Early research by scientists at Lawrence Berkeley National Laboratory has indicated that exterior wall products exposed at a vertical angle experience less albedo loss in the first year of exposure than field-applied roof coatings at a near horizontal slope. That being said, the radiative performance of in-service exterior walls will be affected by various factors, including climate conditions and atmospheric soiling. As we'll discuss later, wall products that obtain CRRC ratings are naturally aged for 3 years to indicate how soiling and weathering may affect their radiative properties. So next up, now that we've provided an overview of why cool exterior walls matter in terms of energy savings and urban heat mitigation, we're going to talk a little bit about the current codes, programs, and standards that contain provisions for these building materials. A growing number of codes, standards, and programs require or promote the use of cool exterior walls. Also, I should point out that cool walls are defined differently depending on the jurisdiction. So there's no one set solar reflectance or thermal emittance that is considered to be a cool exterior wall or not. The state of Hawaii's Building Energy Code is based on the International Energy Conservation Code with state-adopted amendments. The code contains an insulation trade-off and compliance credit for the installation of cool exterior walls. The exterior wall material must have a visible light reflectance of 0.64 or higher. This credit is available for newly constructed tropical homes that meet conditions specified in the code. The state of Hawaii is also currently in the process of updating its building energy code, so it's possible that it will change in the future. Moving on to model codes and standards. First is ASHRAE Standard 90.1, which is a benchmark standard that provides the minimum requirements for the energy efficient design of most building types with the exception of low-rise residential buildings. It is widely adopted by state and local jurisdictions, and it currently contains cool exterior wall provisions for climate zone 0 and offers a small credit for them in climate zones 1 and higher. Starting later this year, ASHRAE 90.1 will also offer a compliance credit applicable to all US climate zones. California's Green Building Standards Code, Title 24, Part 11, is commonly known as CalGreen. And CalGreen is a stretch code that contains a voluntary requirement for cool exterior walls that becomes mandatory when it is adopted by a local jurisdiction in California. The International Green Construction Code, known as IGCC or ASHRAE 189.1, is a model green building code that becomes mandatory when it is adopted by a jurisdiction. It currently contains a cool exterior wall requirement, but ASHRAE is actually in the process of proposing to revise these requirements to align with the 2022 version of ASHRAE Standard 90.1, which I mentioned will include a credit for cool walls in all climate zones in the US. ResNet 301 is a standard for evaluating and labeling the energy performance of dwelling units and sleeping units, including all detached and detached housing types. It requires compliance with minimum solar absorptance, which is solar reflectance -1, as well as thermal emittance values for above grade walls. Lastly, there is also a proposal currently under consideration to adopt ASHRAE Standard 90.1 wall reflectance requirements into the next International Energy Conservation Code, or IECC. This is a model code that regulates the minimum energy conservation and efficiency requirements for new buildings. It is widely adopted by local and state jurisdictions as part of their building energy codes. Next, we're going to talk about voluntary green building standards and programs. Each of the following voluntary programs contain some type of cool exterior wall provision. First is the Green Globes, which is an online assessment protocol, rating system, and guidance for green building design, operation, and management. It provides market recognition of a building's environmental attributes through third-party assessment. Next, the Green Seal Standard for paints, coatings, stains, and sealers establishes environmental health and performance requirements for certain architectural coatings that are intended to be applied on site. The National Green Building Standard, also known as ICC 700 or NGBS, is a voluntary standard for green building design and construction of homes. Lastly, the Leadership in Energy and Environmental Design, or LEED program, is a voluntary green building certification program. It currently offers a heat island mitigation pilot credit for cool exterior walls. We'll discuss the credit a little bit more on the next slides. The LEED version 4.1 Sustainable Sites Pilot Credit for heat island mitigation with cool walls was published in April 2021 and has been extended through April 2023. The intent of this credit is to minimize effects on microclimates and human and wildlife habitats by using cool exterior walls to reduce urban heat islands. To earn this credit, at least 60% of a building's gross exterior wall area, including vertical fenestration, must be surfaced with a cool wall material. No more than 40% of the building's total cool wall area may be sited on the wall facing away from the equator. The credit defines cool wall material as a material that is opaque to sunlight and has an initial solar reflectance of at least 0.6, as well as an initial thermal emittance of at least 0.75. The credit contains specific requirements for the standard test methods that must be used to measure these values. These test methods are all methods that are used in the CRRC wall product rating program. We are currently aware of at least 5 LEED projects that are currently registered for the Cool Walls pilot credit. In the absence of an online directory, users have expressed difficulty finding compliant products that have been tested using the required methods. Third-party ratings from the CRRC are critical in helping end users to identify with compliant products. Obtaining CRRC product ratings, which we'll discuss shortly, can be a great way to promote your products to LEED projects using this credit. If projects continue registering for the credit, it will also have the potential to become a permanent credit that will continue driving end users to products that are listed on the CRRC directory. As we've discussed, cool exterior walls are an important tool for helping to mitigate the growing impacts of heat in our communities. Credible, easy to access data is also important for helping end users understand product performance and identify products that comply with the codes, programs, and standards that we just went over. This is where third-party ratings come in. Third-party ratings inform consumers about rated products' ability to reduce heat gain, help consumers ID higher performing and compliant products, and give assurance of unbiased and verified data. Next up, we'll discuss the CRRC Wall Product Rating Program, which was created to meet this need. All right, so that brings us to the main portion of the webinar, which is a detailed overview of the CRRC Wall Program. The CRRC wall rating program is a new program that was launched in January of this year. It is the first and only rating program for the radiative performance of exterior wall materials. While it is very similar to the CRRC roof product rating program, which many of you may be familiar with, it is completely separate from that program, and it does have some important technical differences. The rated wall products directory is fully built and ready to go live once the first product rating is approved. There were many stakeholders involved in the development of the wall rating program, including manufacturers, suppliers, government agencies, nonprofit organizations, energy utilities, and more. Many of these stakeholders currently serve on the CRRC Board Advisory Committee composed of 25 people that represent 20 different organizations. This committee is responsible for evaluating various aspects of the program, including technical topics related to product testing and weathering. Like the CRRC roof program, wall ratings are based on solar reflectance and thermal emittance, which I briefly described earlier. Again, solar reflectance is the fraction of solar energy that is reflected by the wall, while thermal emittance is the relative ability of the wall surface to radiate absorbed heat. The ratings are based on a scale of 0 to 1, with 1 being the most reflective or emissive. Each wall product will have 2 ratings, an initial rating and an aged rating. Initial ratings are based on the measured solar reflectance and thermal emittance of brand new products, while aged ratings are based on the measurements taken after the specimens have been naturally aged for 3 years. As mentioned earlier, aged ratings are extremely important for understanding how the radiative performance of the materials may change over time. As I mentioned before, the wall rating program is entirely separate from the CRRC roof program. However, there are many similarities, but there are also some significant differences. Like the roof program, the wall program offers initial and aged ratings that are based on measured solar reflectance and thermal emittance values. It requires 3-year natural weathering, and it offers a free rated products directory that is available to the public. Ratings rely on testing by accredited independent testing laboratories that utilize the same industry-vetted test methods. It also offers flexible rating options for different types of products, which we'll talk a little more about later. Unlike the roof program, the wall program uses a different setting when reading the solar reflectance to account for the 90-degree angle of exposure of an exterior wall. It also does not offer solar reflectance index or SRI ratings. This is because the calculation of SRI is in accordance with ASTM E1980, which does not account for a vertical surface. The wall program also does not offer laboratory aging, which we refer to as rapid ratings at this time. Some test data provided by manufacturer testing laboratories is also accepted for wall product ratings, and we're going to talk a lot more about that later. The rating application submission process is also different from the roof program, as we use an Excel template instead of an online rating portal. Lastly, validation testing, or what we call random testing in the roof program, will be incorporated into the wall program. However, that's not anticipated to start until 2025. Due to some of the significant differences that I just mentioned, products with existing CRRC ratings in the roof program or with existing SR and TE data cannot be used for wall product ratings, primarily because the exterior wall setting is not used on the reflectometer and because of the exposure angle. On screen are the currently approved test methods used for measuring solar reflectance and thermal emittance of wall products, which are the same as the methods used in the roof program. However, solar reflectance measurements of wall products must be conducted using the air mass 1.5 global vertical or AM 1.5 GV output for a sun-facing 90-degree vertical tilted surface. To achieve this, the output setting on the measurement device needs to be changed by the operator. Further, version 6 of the Devices and Services Portable Reflectometer must be used to perform ASTM C1549 and the CRRC test method number 1. When the device is used, the operator will need to use the 1590 setting, which requires the version GV9 EEPROM that can be obtained from Devices and Services. The EEPROM is a programmable read-only memory chip that retains its data when its power supply is switched off. And this particular EEPROM is what enables the correct setting to be used on the device. Alternatively, a calibration report can also be obtained from devices and services that can be used to extract the AM 1.5 GV results for measurements taken using the default EEPROM that comes with the device. For solar reflectance tests using the Surface Optics 410 Solar or 410 Solar I, which is another instrument that's approved for the program, the operator will need to also use a different output setting than they would for roofs. This setting is called G197 GT90. Different settings on the SSR provide different parameters for the device. For example, 1.5E focuses on just the direct radiation, while 1.5 GV includes the effects of diffuse light. The V in 1.5 GV refers to it being a vertically oriented surface. The setting accounts for how light interacts differently with the surface based on its orientation. The different device settings and parameters basically change the weighting of each of the 4 sensors to better simulate the precise environment that is being considered for walls. Moving on to thermal emittance measurements. ASTM C1371, which uses the devices and services AE1 emisometer, may be used for factory-coated or bare metal products. All other products must be tested using the slide method, which is published in the Devices and Services Technical Note 11.2. The slide method requires the use of a Model AE ADP port adapter that can be obtained from Devices and Services. The slide method can also be used for metal products, but it is not required. Whether or not ASTM C1371 or the slide method is allowed depends on the material's thermal conductance. Since metal has a relatively high thermal conductance, it is no problem to use C1371. For products that have a lower thermal conductance, the slide method is more accurate since it involves sliding the measurement head to different points on the specimen, which prevents heat from building up in the specimen and potentially skewing the test results. Most of the testing for the wall rating program is done by accredited independent testing laboratories, or AITLs. These are laboratories that have been approved by the CRRC. We also allow certain test data from manufacturer labs. AITLs are required to be ISO accredited, have no affiliation with manufacturing, they must own the proper measurement equipment, and they must attend a CRRC lab training. They must also participate in the CRRC's biannual interlaboratory comparison study for ongoing performance evaluation. Approved manufacturer test labs, which we call AMTLs, are also allowed to submit data for certain product and rating types in the wall program. Manufacturers of factory-coated metal, as well as architectural coatings, are eligible to become AMTLs. AMTLs must own the proper testing equipment, attend a CRRC training, and provide documentation of their quality procedures. They also must participate in the interlaboratory comparison study. AMTLs are able to submit product rating data for color family additional element ratings, which I'll go into a little bit more detail on later. Currently, 3 AITLs offer testing for the wall program. Additional AITLs that currently only participate in the roof program may also be added in the future. And you can see the contact information for our current AITLs on screen. There are also 2 active AMTLs in the program, Sherwin-Williams Coil Coatings and Behr Paint Company. And the contact information for our AITLs is also available on our website at coolroof.org. As mentioned earlier, wall product samples also need to undergo 3-year weathering at CRRC-approved test farms in 3 designated U.S. climates. Test specimens are exposed at a south-facing 90-degree tilt and staggered to prevent any potential cross-contamination between specimens. Both of the test farms in the roof program provide weathering for the wall program, which, and these are Atlas and QLab, and their contact information is also available on coolroofs.org. Next, I'd like to take a moment to describe the standard rating process as well as some additional rating options for the wall rating program. The default standard rating process comprises of 8 steps. For initial ratings, the first step is for the manufacturer or seller to become a CRRC wall licensee. The wall licensee then completes a product rating application with the product information and sends it to the lab and the CRRC. The AITL will test the specimens and report the data to the CRRC, and then the CRRC will review and approve the data. At that point, the CRRC will invoice the licensee for the product rating fee, and once it is paid, the product rating will be published on the rated wall products directory. After initial testing is completed, the AITL sends the specimens to the test farm for 3-year aging. After aging is completed, the specimens are sent back to the AITL to perform age testing. The age test data is then submitted to the CRRC, reviewed and approved, and published in the age ratings on the directory. In addition to the default standard product rating, there are 3 other rating options that licensees can choose from. First is reference ratings for privately labeled products, compound ratings for products that come in various shapes or profiles, and color family ratings for products that come in hundreds or thousands of different color shades. Reference ratings are a rating option in which the product inherits measured data from another CRRC rated product. A common example of this would be private labeling. For a reference rating, the product manufacturer, company A in the example on screen, manufactures the product and obtains a standard product rating. Company B, which is a different company bringing the product to market, may submit a reference rating application that will inherit the rated data from company A's application. A reference rating itself can also be further referenced by another licensed seller. To obtain a reference rating, both the manufacturer and seller must be CRRC rating program licensees. The manufacturer must give authorization for the rating to be referenced by the seller. No additional testing is required for reference ratings, since the test data is inherited directly from the referenced or parent product that already has data. Reference relationships are kept confidential between the licensed seller, the other manufacturer, and the CRRC. In other words, the reference relationship is not made public on our rated products directory. Lastly, because the product is referencing another rated products ratings, any changes to the product's formulation may affect the ratings, particularly if the radiative performance of the parent product significantly changes. Another rating option is compound ratings. Compound ratings are available for products that are available in multiple profiles or shapes, but have the exact same surface formulation. In a compound rating, all profiles must undergo initial testing to determine which profile has the lowest solar reflectance. The profile with the most conservative value is rated and must undergo weathering and age testing. The brand and model names for each of the other profiles will be included in the listing, and they do not need to undergo age testing. A few notes that are about metal products in particular. If a metal product is produced as a smooth panel that is installed in different macro level profiles, for example, standing seam, just the flat metal panel needs to be rated and no compound rating would be necessary. If a metal product is actually stamped or textured with a different pattern or texture, for example, a wood grain, then each of the different textures of that same product could be part of a compound rating. Options may also be available for combining a compound rating with a color family rating, although a current procedure for that is not yet in place. Lastly, color family ratings are available for products that come in hundreds or even thousands of shades. They are offered for factory coated metal as well as field applied architectural coatings. Similar colors from the same product line may be grouped together in a color family group. One product in the group must undergo weathering while the rest do not. All products submitted for color family ratings must be tested for solar reflectance, thermal emittance, and color imagery. Color is measured because members of a color family group must fit within a defined color range for that chosen group. There's a few terms that you should be familiar with when applying for a color family rating. First is the representative element, which is the product with the lowest solar reflectance, and it establishes the color family group. The representative element must be tested by an independent test lab, an AITL, and it must undergo 3-year weathering and age testing. An additional element is a product that inherits the age data from its representative element. Additional elements have their own initial test results published, but their aged results are identical to those of the representative element. Initial and colorimetry testing may be performed and submitted by a manufacturer test lab for additional elements. In order to establish a color family, a licensee may submit its own test data or data provided by an AITL for a color family group to the CRRC. The CRRC will identify which product will become the representative element, which must then be sent to an AITL for initial testing and aging. The remaining products can become additional elements, which will have the same manufacturer provided initial results published on the directory. I just want to clarify, they will have their own manufacturer provided results published. So each one will likely be very slightly different. In the roof program, color family elements are assigned solar reflectance and thermal emittance values based on established values that we have laid out in our program. By contrast, the actual initially tested data for all elements is published for the wall program. And you can see on screen the different defined color ranges for metal products in the wall program. So moving on, next we're going to talk a little bit about product listings and labels. So basically how your product information is made available to the public. Most importantly, each rated product will appear in the online CRRC rated wall products directory, which is modeled closely after our roof directory, which was actually just redesigned at the beginning of this year. Users of the directory will be able to search for products that comply with various codes and standards, as well as any personal building goals that they have for their property. The example on screen contains dummy data. Actual ratings will be published once they are available. And just as a side note, there are currently 5 licensees in the wall program, and we are aware of at least a few products that are currently in the process of being tested. So we do expect that the directory will go live in the coming months. In the directory, consumers will also be able to search for rated products by type, color, solar reflectance, etc., using preset search filters. Users will also be able to sort the results by the date it was added to the directory, product ID, manufacturer, brand, and other options. Additionally, users will be able to easily navigate to the roof directory, share a link to product results or a product listing, easily contact tech support, export the directory to Excel or a CSV file, and also print the directory results. Users will also be able to click the 3 dots on any given listing to view additional product details, such as contact information or the licensee's website. In addition to the wall directory, rated products are also identifiable by the CRRC rated wall product logo and rated wall product label. These are optional marks that the licensee can choose to use on their rated products, but they are not required. The rated product label includes the CRRC ID of the rated product as well as the actual rated values, while the rated product's logo simply indicates that the product is rated and that the consumer can search for it on the directory for more information. Okay, lastly, we're going to go over participation details for the program. Companies that are interested in rating wall products must first become a CRRC wall licensee. This is completely separate from roof licensee status. To become a licensee, simply submit a licensee application and agreement and pay the licensee annual fee. The application and agreement are both downloadable files available on coolroofs.org. Licensee fees are paid annually and they are prorated for the month of application during the first year. The fee is determined by the company's annual sales of exterior wall products, which is the total global sales of exterior wall products for the company. And it is not limited to just sales of CRRC rated products or regional sales. To have a product rated, a licensee should first engage with the CRRC approved lab to perform initial and age testing. You should also contact a test farm to arrange for product weathering. Once testing and weathering has been arranged, you will complete a product rating application and provide it to the test lab as well as the CRRC. The CRRC will review and file this application upon receipt but we will not invoice you or publish any product information until the test results are received and approved by the CRRC. Once the test results are submitted to the CRRC by the AITL, we will invoice you for the product rating fee. When the fee is paid, your rating will be published on the directory and you will be authorized but not required to use the rated product logo or label. More information about the rating process is available on coolroofs.org. These on screen are the initial and annual rating fees. Initial fees are a bit higher to cover application processing, while renewal fees cover maintenance of the program. As you can see, the fees also vary by rating type. Licensees also have the opportunity to become an AMTL. To become an AMTL, a licensee submits an AMTL application and agreement, along with documentation of written testing procedures, training records, a system for retaining test records, and a system for calibrating equipment. The AMTL applicant must also participate in a CRRC laboratory training and then test a set of wall product specimens that are supplied by the CRRC to demonstrate proper equipment settings, calibration, and operation. Lastly, AMTLs pay an annual fee of $1,500, which is also prorated for the first month of application. Finally, another way to participate in the program is to join the Wall Rating Program Committee or attend its meetings as a guest. A list of upcoming meetings is provided on this slide and can also be found on the CRRC website. You may notice that our next Wall Program Committee meeting is actually tomorrow. So if anyone here today is interested in attending that meeting as a guest, please feel free to reach out to me and I can send you an invite. If you're interested in learning more or being added to the committee distribution list, please feel free to contact me. Lastly, before we go to questions, I would just like to invite you to follow the CRRC on LinkedIn and Twitter. On our social media sites, we post regular updates about the WALL program and the CRRC in general, and that's really the best way to stay up to date with the most current information about what's going on in the program. That being said, I'd like to thank you all so much for your attention and turn it back over to Kaylin to manage the Q&A session.
Absolutely. So thank you again, Audrey, for joining us. And if anyone has any questions, please feel free to submit those either through the Q&A button at the bottom of your screen or through the chat box. I'll monitor both of those. Audrey, we do not have any questions yet, but I would love to hear a little bit more. How did you get involved in the CRRC?
So before I was hired by the CRRC, I've worked here now for about 1.5 years. I worked for Intertech, which is a testing, certification, quality assurance organization. So Intertech actually provides testing for the CRRC. So that's how I learned about the organization and eventually got my position here.
That's amazing. Wonderful. Well, we still do not have any questions, so I'm going to take it that you were just that comprehensive, answered everybody's questions. But again, if anyone does have any questions as we wrap up this webinar, you can absolutely reach out to Audrey. And her email address is audrey@coolroofs.org. Again, it is on the screen right now. And if you do have any questions about future MetalCons, you can reach out to me at kaylin@metalcon.com. I'm always happy to answer any of those questions. Again, thank you everyone for watching today. Thank you for joining us. We appreciate you taking the time out of your days. And Audrey, thank you so much again for being here and for doing this presentation. We appreciate everybody. We hope to see you at MetalCon in a few short weeks. Thanks, everybody.
All right. Thank you so much. It was a pleasure.
Thank you. Bye.